Today we will be solving systems with substitution. This is day 2 of your notes. So like yesterday, a couple of things that we're looking for. Remember, it's easiest to use substitution when both equations in the system are in slope-intercept form, so y equals mx plus b, or you have one equation in slope-intercept form and the other equation in standard form. So let's take a look at problem A. Both of these equations are written in standard form. However, this first equation can easily be solved for y and put into slope-intercept form. So that's what I'm going to do for this top equation. So the first thing I want to do is I want to subtract 6x from both sides of the equal sign. When I rewrite it, that becomes y equals negative 6x plus 11. And then I'm going to keep my bottom equation the same, so that's 3x plus 2y equals negative 5. Now, like we learned yesterday, when y is equal to negative 6x plus 11, we can easily substitute that into the second equation. So when I do that, I get 3x plus 2 times y, and I'm going to write that with the parentheses again, and that's all equal to negative 5. Now what goes in parentheses is what y is equal to, so negative 6x plus 11. And now I'm going to have to distribute if I want to solve for x. So when I distribute, 2 times negative 6x is negative 12x. 2 times 11 is 22. I didn't use equals negative 5 or the 3x out front. Now I want to combine like terms. So 3x minus 12x is negative 9x. Bring down the plus 22, all equal to negative 5. And now I'm going to subtract 22 from both sides of the equation. So negative 9x, that makes 0, so it's canceled out, equals negative 27. In order to get x by itself, divide both sides by negative 9. And I get that x is equal to a negative divided by a negative is a positive. 27 divided by 9 is 3. Now that I found the value of x, remember, my answer is going to be a coordinate, so 3, comma, some y value. I'm going to take 3 and I'm going to plug it back into this equation that I solved for y. I do that because once I plug in x, I just have to simplify here, and then I'll have the value for y. So y equals negative 6 times x, so I'm going to use parentheses, and then plus 11. So what goes in the parentheses? The value of x, which is 3. So negative 6 times 3 is negative 18. So y equals negative 18 plus 11. When I simplify here, I get y is equal to negative 7. So my solution here is 3, comma, negative 7. In the second problem here, B, here I'm going to try to attack it the same exact way. I can solve either this top equation for x to get that by itself, or I can solve the bottom equation for x. However, I would have to divide by a negative 1 here. So I'm going to take this top equation to solve for x. So I'm going to add 3y to both sides of the equal sign. So if I rewrite this, I get x equals 3y plus 2, and in my bottom equation I have negative x plus 3y equals negative 5. So now that x is by itself, I'm going to substitute this in for the x in the bottom equation. So the opposite of x plus 3y equals negative 5. So what goes in the parentheses is 3y plus 2. And now I want to distribute that negative. So I get negative 3y minus 2 plus 3y equals negative 5. Combine like terms. So negative 3y plus 3y That makes 0, so it cancels out. So negative 2 equals negative 5. Again, you have to ask yourself, is this a correct solution? And here the answer is no. So this is no solution. In C, here I have 7x minus 2y equals negative 3. Negative 4x plus y equals 1. So again, like the previous problems up above, I want to go ahead and solve either the top equation or the bottom equation for one of the variables. The bottom equation makes the most sense, so I'm going to add 4x to both sides. When I do that, I get y equals 4x plus 1. And now I'm going to take, since y is by itself, 4x plus 1, and substitute it in for this y here. Okay, so I have 7x minus 2 times y equals negative 3. What I'm substituting in for y is 4x plus 1. And now I want to solve for x. So distribute. Negative 2 times 4x is negative 8x. Negative 2 times 1 is negative 2. Equals negative 3 at the end with 7x out front. So combine like terms. 7x minus 8x is negative 1x, or just negative x. Minus 2 equals negative 3. Add 2 to both sides. So negative x is equal to negative 1. And now we want to divide both sides by negative 1. When I do that, I get that x is equal to positive 1. So remember, our answer is going to be 1 comma some y value. And now I'm going to plug it back into this equation here. So I know that y is equal to 4 times x plus 1. When I substitute in 1, 4 times 1 is 4. 4 plus 1 is equal to 5. So my solution is 1 comma 5. So now at this point you can go ahead and pause the video and try the U-tries on your own. When you finish completed those, go ahead and unpause the video and I will have the solutions for you. Okay, for A, if you solve this problem correctly, you should have gotten no solution. And in B, if you solve this problem correctly, you should have gotten the coordinates 4, comma 2. So now let's go ahead and take a look at example number 2. Here we're going to be talking about the word problems, the application of the system of equations. So kind of like what we did with elimination, we want to set up two equations here. We want to use variables that make sense for the problem. Okay, so it says Kathy and Dante sell home theater systems. Kathy earns a base salary of $2,300 plus $200 for each system that she sells. Dante earns a base salary of $2,500 plus $150 from each system he sells. How many systems do Kathy and Dante have to sell before they earn the same amount of money? Okay. So I'm going to set up two equations here. One equation that talks about Kathy and the other equation that talks about Dante. Now they're selling these systems, and what they're trying to do is they're trying to make a profit. Okay, so I'm going to let P represent their profit. And then I'm going to let S represent the number of systems that they sell. So Kathy's profit is going to be equal to her base salary of $2,300 that's not going to change whether she sells one system or 100 systems. She's still going to make that $2,300. And then here it says plus $200 for each system that she sells. So that's 200 times the number of systems. So Kathy's equation is P equals 200S plus 2,300. Now for Dante, he's going to make a profit as well. So P still applies to his equation. And it says that he earns a base salary of $2,500. So he actually earns more than Kathy does. However, he earns an additional $150 for each system that he sells. So he earns a little bit less for each system, but his base salary is more. So that would be $150 per system. So like we learned yesterday, P in both equations is the exact same. So since it's the same in both equations, what we can do here is we can solve this system by setting 200S plus 2,300 equal to Dante's, because it says how many systems do Kathy and Dante have to sell before they earn the same amount of money. So we want their profit to be equal. So again, 200S plus 2,300 equals 150S plus 2,500. So now I want to get the variables to one side and try to get the numbers to the other side. So I'm going to subtract 150S from both sides. 200S minus 150S is 50S plus 2,300. That's eliminated. Is all equal to 2,500. Subtract 2,300 from both sides. And I get that 50S is equal to 200. So divide both sides by 50. 50 goes into 200 a total of 4 times. So they have to sell each 4 systems for their profit to be the same. Okay, go ahead and turn the page. On the next page here, in problem B, it says, Reggie is running a race with Tom. Reggie is already 3 miles in and is running at a pace of 4 miles per hour. Tom is already 5 miles in and running at a pace of 2 miles per hour. How long will it take for Tom and Reggie to meet up? So they're asking, at what point will they have ran the same distance? Okay, so I'm going to have 2 equations here. I'm going to have one equation for Reggie, one equation for Tom. Okay? So it says Reggie is already 3 miles in and is running at a pace of 4 miles per hour. So Reggie, okay, if we talk about his total distance, so D represents distance here. His distance is equal to the 3 miles that he's already in plus his pace of 4 miles per hour. So I'm just going to say 4m. So m will represent my miles per hour. So Tom is 5 miles in. So his distance is already at 5 miles in and running at a pace of 2 miles per hour. So that would be 2n. Okay. So it says, how long will it take for Tom and Reggie to meet up? So we're talking about hours there. And then how many miles will they have gone? Okay. So D would be represented in miles, and M really shouldn't be miles per hour, but more or less should be H to represent the hours. So I'm going to go ahead and change that now. So H is really hours. So like we did in the last problem, take Reggie's equation, 4m plus 3, and set it equal to times, so that's 4h plus 3, set that equal to 2h plus 5. So now we want to find out when are they equal. Okay. So now I'm going to subtract 2h from both sides. When I do that, I get 2h plus 3 is equal to 5 because that makes 0. Subtract 3 from both sides of the equal sign, so 2h equals 2. Divide both sides by 2, and I get that h equals 1. So that means that in 1 hour, they will have gone the same distance. And we can substitute that in and find out that that's true. So 4 times 1 is 4, plus 3 is 7. 2 times 1 is 2, 2 plus 5 is 7. So when I plug in 1 here, d equals 2 times 1 plus 5. So d equals 2 plus 5. So the distance is a total of 7 miles. So in 1 hour, they will have gone 7 miles. At this point, you can go ahead and hit pause. I want you to try you try A on your own. When you finish the problem, go ahead and unpause it, and I will have the solution for you. Okay, so the solution for A is 300 bikes, and the amount of money that they will make is a total of $6,000.